Hello everyone. Today our group, I Apurv, Gaurav, ANMOL, AADITYA, SAHAY and SPANDAN MITRA will be going to show you a tutorial 5 for the mechanism session. So the question was to synthesize and make a simulator for a garage door mechanism that does not have any prismatic or higher pair. We were supposed to show the synthesis process, simulation approach and the working of the simulator. So first let us discuss what is a 4R linkage. A 4R linkage in this case is a setup of four rotating joints with four revolute pairs, where the link that is grounded is called the ground link, and the two links which are connected to the ground hinges are called the input and output link. The link which is not directly connected to the ground is called the coupler link. So why we have chosen a 4R chain for a garage door? A 4R chain is chosen above a prismatic link because it was also mentioned in the question, and as well as due to high friction in the prismatic links, the wear and tear is more and the maintenance of link becomes expensive. We preferred the 4R linkage over the 6R linkage, 6-bar linkage, because the 6-bar linkage mechanism requires a multi-stage synthesis process, which is a complex process, where in this case, a 4R chain synthesis is a straightforward process. So let us look into the synthesis process. So the idea behind the synthesis is that we have the extreme configurations. The first one being the horizontal position when the door is open, and we have taken the horizontal position because we were supposed to keep the space occupied by the door when open lesser. So that is only possible when the door is horizontal and touches the ceiling in the open position. The second extreme position is when the door is closed and the door is obviously vertical. So for synthesis, we have taken the coupler of the 4R chain to be the garage door. So there are two approaches for synthesis. First being the two-position synthesis, and second being the three-position synthesis. So in the two-position synthesis, we have two configurations of the door, which is the horizontal and vertical configurations. We have 2 points A and A2, and similarly B and B2. We draw perpendicular bisectors of A and A2 and B and B2, and ground links can be found on those perpendicular bisectors. This figure shows what actually two-position synthesis looks like. So the ground link lie on A and A dash, and the second ground link lies on B and B dash line. So now we look into the three-position synthesis. For a three-position synthesis, we need three configurations, but we have only two configurations, so we'll have to arbitrarily assume an intermediate configuration to get the third configuration for position synthesis. So for third configuration, we arbitrarily choose a third configuration between the first and second configuration. So now we have three configurations as shown on the screen. So the synthesis process looks like we have three configurations, 3 points A1, A2, A3, and similarly B1, B2, B3. For the first ground link, we join A1 and A2, and similarly A2 and A3, and the intersection of the perpendicular bisector gives us the ground link O2. We do the same process with B1, B2, and B3, and the intersection of their perpendicular bisector gives us the second ground link, which is O4. Now we join O2 with A1, A1 with B1, and B1 with O4, which gives us the 4R mechanism, where A1, B1 is actually the coupler. This is the step we have followed for synthesis as discussed earlier.
So here we will be looking at the simulation approach. So as we can see that in the parameters, firstly we took the link AB, which is the coupler, and we had taken three positions, namely horizontal, vertical, and an intermediate position. And with the help of synthesis, we found the value or the position of O2 and O4. So this is the thing which we found, and along with that, it helped us to find the values of theta2 and theta4, and where theta2 and theta4 are calculated to make the exact mechanism for the simulation. And now that we have the required lengths and measurements, we can build the exact mechanism. So in the next slide, we can see this is the overall like a boundary of like a front view of what is there in the mechanism, and the simulation will be shown in the inlay like just now.
So I will be showing the working of simulations. We used platform linkage. Here we can see the mechanism in 2D. Initially, this link 3, which is the door, acts as a coupler and is at initially is horizontally placed. So in the mechanism, it rotates clockwise. So I will be showing the mechanism now. The mechanism works as follows. We also made a 3D simulation using Blender.
So in the next part, we will be talking about innovations and automations. So as we can see, for automation, we can use gears, motors, and various electromagnets, where we can attach an electrically powered motor to the input link. Using gears, we can achieve the required speed with which the garage door moves and rotates. We can have strong electromagnets on the top of the position, where in this case, when the switch is turned on, the input link rotates to the motor under the influence of gears and slowly rises to the horizontal position due to the action of the electromagnet on the ceiling, where the electromagnet holds the door till the switch is on. So in the next part, we will be discussing about why we used why we used a 4-bar linkage instead of 6-bar linkage. So the 4-bar linkages are cheaper to manufacture and they could serve the purpose. Even though we have seen that 6-bar linkages could be better in some cases, and these cases are where the space available is less. A 6-bar linkage is better suited, as in a 6-bar linkage, for the same rotation of the input link, the vertical height achieved can be higher. Like in other words, for the same configuration, the ground hinges would be closer to the door, making it more space efficient. So this is what we have done, and we have shown it. And so thank you.